Hello, good morning students, and welcome back once again to another video for class 10th. And today we are starting with the magnetic effects of electric current. And as you know that this chapter is all theoretical based questions, so we won't be having any numericals, but we will be having a lot of knowledge based questions as well as theoretical questions. Okay, so pay attention. The first question is, which of the following describes the magnetic field near the long straight wire? So we are talking about a straight conductor carrying current, and it is on the very first page after the magnetic effect of a permanent magnet. We have the first one topic, that is the electricity or the magnetic effect of the first straight conductor carrying current. And as you know that in this particular point, the magnetic field is in concentric circles, that is around in circular form on around a wire or a conductor. So let's see the options. What are the options? And the first option is, the field consists of straight lines. It is not specified what kind of straight lines, and moreover straight lines are not the magnetic field around a particular straight conductor. And second one is, so the first option is wrong. Second option, the field consists of parallel lines. Once again, what kind of parallel lines? It is not mentioned. Okay. And the third one is, the field consisting of radial lines originating from the wire. That means if this is the wire, then from the point they are originating, they are coming out of the wire, and that is what they are trying to say. Once again, this is not the magnetic field of a straight conductor. And the fourth option is, the field consists of concentric circles. Yes, so this is the one. If you remember, this is a straight wire and the field around it is somewhat like this. As you go far and far away, the field strength decreases. So it is stronger near the poles, but more importantly, it is in the form of concentric circles, not any kind of straight lines. So the answer for the first one is D. That is, the field consists of concentric circles. Second one, the phenomena of electromagnetic induction. So what is electromagnetic induction? It was first introduced by Michael Faraday, that we studied in the topic. It is the production of electricity, okay, or generating induced current by moving the magnet around the coil or moving the coil around the magnet. In any ways, if there is a relative motion, then the electricity is generated in the coil. So let's see the options. Which one is the correct one? First one, it is the process of charging a body. No, we are not charging a body. That we already studied in class 8. By rubbing a body with a plastic or a woolen cloth, we can charge it, or by rubbing a particular plastic on our hair, we can get it charged. That is not the point. Second one, the process of generating magnetic field due to current passing through a coil. Now this is not the phenomena. It is actually the opposite of electromagnetic induction. This was first discovered by our scientist, that is the German scientist, that if you pass current in a straight conductor, then it generates magnetic field. Okay, Oersted, Hans Christian Oersted first introduced this when he was studying electricity. He discovered that a particular straight conductor also generates magnetic effects. So this is not induction. Okay, and the third one, the process of producing induced current in a coil due to the relative motion, like I said. So this is our correct answer. And just for the sake of it, let's see the last point, the process of rotating a coil of an electric motor. No, so there is no need to rotate the coil. It already rotates by itself. That is not the name for this particular point. Okay, so when you are producing induced current, it is known as electromagnetic induction. Okay, moving forward, the device used for producing electric current, this is quite simple, generator, first one. Okay, second one is galvanometer. Galvanometer is actually used to measure the potential difference across the two ends of the conductor, but its needle is in the center. It can produce or it can show the potential difference on both the ends. Okay, so if you have a potential difference attached, that is a battery, then if the potential difference is coming across this way, then it will show the pointer in this direction, and if the potential difference is across the other side, then it will show the pointer on the other direction. Okay, second one is ammeter. Ammeter is used to measure the current, and D is motor. Okay, so motor is not a device used for producing electric current, it is generator. Okay, the last one, The essential difference between the AC and the DC generators, okay, I have accidentally wrote motor. The essential difference between the AC and the DC generator is, so we are supposed to find the out of these four options, which one is the difference between the AC and the DC. Okay, for we already know that AC current uses, AC generator uses or produces alternating current, and DC generator produces DC current. They are similar to AC motor and DC motor, but let's first see the options. AC has electromagnet while DC has permanent magnet. We know that for simplicity purpose, in AC and DC generators or motors, we always use a permanent magnet. Okay, I repeat myself. We know that in AC generator and DC generator, or AC motor and DC motor, in both the cases we always use a permanent magnet. We do not use an electromagnet for simplicity purposes. So this option is wrong. We never use electromagnet, we always use permanent magnet for simplicity purpose. Second one, DC generator generates high voltage. Not necessarily. If you have a powerful enough motor and a strong magnet, it can be the voltage can be produced according to our liking, whether it is high or low. Similarly, the third option, AC generator generates high voltage. Once again, you can generate potential difference according to the magnet and the strength of the coil, or how fast you are rotating the coil, or how much is the speed of the rotation. So it all depends upon the rotation and the strength of the magnet. It can be either high voltage or low voltage, it does not matter. Okay, so these two options are once again wrong. The last one, AC generator has slip rings while DC generator has commutator. Yeah, so this one is the correct option. We know that in AC generator, when the coil is connected, if you remember the diagram like this, then one of the line is connected with the ring and the other one is also connected with the ring, so that whenever this rotates, the current passes once through this side and once through this side. That is why they both have slip rings. Okay, but in DC generator, we had split rings. If you remember, the structure is somewhat similar, but both the wires have half of the rings like this. One is like this and the other one is also like this, so that whenever it completes half the rotation, once again the rotation is reset and the current flows in the same direction. Because in DC generator direct current, the direction of the current does not change. However, in alternating current, like the name suggests, the current alternates, one from this direction and the next time from the other direction. So it fluctuates. Once from the direction of the current is in this side and the other one is this side. We don't want that in direct current. So that is why there have been split rings, so that when it rotates, the current always comes from either this side or this side, depending on the direction of the motion and the magnets placed. So the commutator is basically split rings that keeps the direction of the current in the same particular line, other than rotating it. Okay, so this is the main difference. This is what differentiates AC generator from DC generator. Otherwise everything else is the same. The coil is the same, the magnets are the same. The only difference is the slip rings and the split rings. So our answer is D, that is AC generator has slip rings while DC generator has commutators. Okay students, so these are the four simple things that we studied during the whole chapter, and the exercise is also going to be based on such simple questions. If you have your knowledge correct, then answering these questions are quite easy. Okay, so this type of questions are also asked in the board examinations, and for this you don't have to understand any of the numericals and other complicated stuff. However, your knowledge has to be perfect. If you understand all the topics correctly, then answering these questions will not be difficult for you. Okay, you just have to sharpen your knowledge. That's it. Okay students, have a nice day.